All right, the best part, synthesizing molecules. That's what organic chemists love to do. Okay, so now we have all these new tools with reduction reagents, organometallic reagents, so we can make a lot of new carbon-carbon bonds in new interesting ways. Our previous ability to make carbon-carbon bonds was basically just alkynes with SN2 reactions. Now we can add Grignards or organolithiates to carbonyl compounds, and if we wanted to, we could use cuprates for alpha beta, unsaturation, addition to that beta position. But essentially, a lot of questions are going to look just like this one, where it tells you this is your starting material. You can also use alcohols that are 3 carbons or less, and this is the product that we have to get to. So how do we do that? Just looking at the product, we can see that essentially the 6-membered ring is still there. The carbon that's attached to that 6-membered ring will be right there. So essentially the new bonds that are being made are right here and right here. So we have to somehow put those new bonds together. So we know that nucleophiles that would be 3 carbons long could be accessible. So something like a 3-carbon chain and then lithium. But will that work with just adding it to the starting material? No, of course not, because we have an acidic proton right here, this OH. So if we added the organolithiate to that, it's just going to deprotonate that. We need to make this a carbonyl compound so that we can add the organolithiates to that. So that's one thing, and also we have to be able to synthesize that organolithiate. So we're going to do that from alcohols that are 3 carbons or less. Essentially we need just 3 carbon chains. So if we had an alcohol that was like this, and we are able to turn that OH into the lithium or the magnesium bromide, then we'll be set to go. So how do we do that? We need to have the halogen in the place of the OH so that we can make the lithiate or the Grignard reagent. So to do that, we're going to use a reagent that you learned back in Organic Chemistry 1. We'll use PBr3. It essentially, one of these bromines is going to replace the OH. It's a substitution reaction. If you're interested, and if it would probably help you understand it if you go back, it's in chapter 9, kind of the last third of the chapter, I'd say, is where you're going to see PBr3. So that transforms the alcohol into the bromide. We would then need to make the nucleophilic organometallics, so we could either use magnesium or lithium. I've been using lithium a lot. This time I'm going to use magnesium, Mg0. We have to remember we're using it in aprotic reagents. We can't have any acidic protons around, so there's our diethyl ether that I put that in. So that provides us with this Grignard, which again, we can think about it as being a nucleophilic carbon, a negatively charged carbon atom, being balanced by an ionic bond to the MgBr. So we have to also turn this into the electrophile. Now we have our nucleophilic component, we have to turn this into an electrophile. So to do that, we need to oxidize this alcohol to a ketone. So if you think back to chapter 12, that's when we did that. PCC was the reagent to make the aldehyde. We had to use some organic solvent for that. That was dichloromethane, DCM, which is CH2Cl2. So that is going to oxidize us to the aldehyde. At this point, we can just add one equivalent of our Grignard. So if we add this Grignard in our aprotic solvent, diethyl ether, that's going to add these 3 carbons to that position right there. That's our first reagent. Our second reagent is just an acid quench, so H3O+. That would provide the alcohol with one of our groups on there, but it can't add 2 times. It can only add 1 time. So we have to add it once like that. Then we're going to reoxidize. So we're going to use PCC and DCM again. That will produce the ketone. And then we can just, again, we've already made this organometallic. We have more of it back in the cupboard. So we're going to then add our organometallic and another water quench. and that will allow the second equivalent of the propyl group to add in there and to make our other bond. So that's kind of the process. So what do you do when you're trying to synthesize something? Look at where the heteroatoms are. This OH had to have come from a carbonyl of some sort, because that's the only way that we can add these nucleophiles to it. So that's kind of our first example of using all these reagents together in synthesis, and there's a couple more coming in the page. So do them on your own first, try them, try to figure out how you're going to go from there to there, and then go ahead and see the videos, and that might give you some additional guidance. So all right, synthesis is fun.